This is the question of 3b. If closed 0 to 1 to r be continuous on 0, 1, and if assumes only rational values. Okay, so if is defined only for rational values, it is undefined for irrational values. Okay, so if assumes only rational values. Now if f of half is half, then prove that fx equal to half for all x in its domain actually. Okay, so we need to show that fx is a constant function which is half, and the given is f of half is half. So now let's talk about the approach. So how we are going to approach? Okay, let's say this is 0, this is 1, and this is half. So f of half is half, so it is 1 by 2 here. Okay, it is 1 by 2 here. Now we don't actually know what is f0, what is f of 1, or the other values except this one. This one is half. Okay, so now how we're going to approach this is, first we are going to take a point from 0 to open half, which is not half but less than half. Okay, but or before the half. Okay, so open half, let's say x1. We take x1 from 0, from closed 0 to half. So okay, so x1 belongs to closed 0 to half, and we're gonna show that x1 is equal to half. No, f of x1 is equal to half. Okay, so we're gonna show that f of x1 is equal to half. Okay, and then by same method we're gonna show that x1, now x2 taken from this interval closed 1 to open half, as f of half is already given, f of half is half. So then by similar method we are going to show that x2, which was taken from open half to 1, f of x2, which is equal to half. So the whole thing becomes half. So we're going to show that first. This is how we're going to approach this question. Okay. So let me draw it here actually. This half, 0, 1. Okay, we're taking x from here, x1, and x2 from here. So now we're going to set this. So now so let x1 belongs to closed 0 to half. Okay, closed 0 to half. Closed 0 to half. So now two cases arise. Okay, so either let's say f of x1 is equal to half, or f of x1 is not equal to half. Okay, so f of x1 is equal to half or no, or not equal to half. So if f of x1 is half, okay, we get what we have wanted. we get what we have wanted. And, but if f of x1 is not equal to half, then what we're going to do? So if f of x1 is not equal to half, then what's going to happen? Okay. Okay. So now, let's say so as this 2 is not equal to half, and what is if so this equals to f of x1 is not equal to f of half, as f of half is half. So now f of x1 is not equal to f of half. So as they're unequal, there must be a real number between them. Okay, so let q, or let's say let there exist a irrational number q belongs to these 2 points. So open f of x1, f of half. Okay, so q belongs to these 2 points, this interval actually. So q belongs to this interval. Okay, so q belongs to this interval. Now q belongs to this, and f is continuous, and q belongs to this, and they're also unequal. Then by intermediate value property, which is IVP in short form, we get by intermediate value property, we get f of q equals to c, or more precisely, there exists a c, say c1 belongs to x1 comma half, such that f of c is equal to q. Okay, but this cannot happen. Okay, this thing cannot happen, as it is contradicting the fact that f assumes only rational values, but q is irrational here. Okay, so this thing is imaginary, this thing cannot happen actually. So which is a contradiction, Okay. So now what do we get? So our assumption is wrong. So this was our assumption. Okay, this is wrong. So our assumption is wrong. Our assumption is wrong. So this was wrong. Therefore, f of x1 is equal to half. Okay, f of x1 is equal to half. So what do we get? F of x1 is half f of x1 is half for all x1 belongs to close to 0 to okay. So now similarly we can show that, so let's say, so we're gonna write that similarly we can show that, so similarly we can show that f of x2 is equal to half for all x2 belongs to open half to 1. All clear now? Okay, so this is half, every value between them is half, every value between 0 and 1 also 1 is half, and this is also half. So am I right? And f of half is half. So what do we get? So f of x1 is half, x1 is 0 to half, half to 1 is also half, and f of half is also half. So fx is half, fx is half. Okay, fx is half for all x belongs to so f of, so therefore f of x is equal to half for all x belongs to 0 to 1. Proved.